Hello and welcome to the 6th Solfem v3 tutorial. In this tutorial we are going to export a step file from your CAD program of choice. I'm using FreeCAD here. We are then going to mesh that step file in the Gmsh program. And then we will export the TET mesh to a text file which we can import into Solfem and run our solution. So I've already drawn up a small simple structure here, and this is just to show how the program works. It's not doesn't need to be like anything realistic, but let's export this file, and you'll want to save it as a step file. So we'll save it there, and then we can start up Gmsh. And in Gmsh you click the file button, file menu, the file we just created, the step file. We open that, and here we can see it. Now these sides are 2 millimeters, and this is 4 this is way too thick, but it doesn't matter. We will go up here in the tools options under mesh and general, and here we will set the element size that we want, and I think we will want, let's go for 2, or between 1 and 2. And here we can, if we slide this to the right, we will get the second order element, so that will be 10 elements. And if we leave it, slide it to the left, it will be first order element, so that will be 4 node TET elements. We will use 10 node TET elements. So first you mesh the all the lines by clicking 1D, and then you mesh all the surfaces by clicking 2D, and finally click the 3D button. It will mesh the volumes. Now the mesh is ready, and we can export to our Solfem v3 work directory. We can call it tutorial 6.bdf. So that's a bulk data file, and also down here select file type Nostrum bulk data file BDF. That's good. And here you have to select the format free field. The other two will not work when you try to import into Solfem v3. And I just always select physical entity here. I'm not sure what's the difference. Okay. And Now we can open a new terminal window, navigate to the solvemv3 work directory, and start up the script program.py and select the viewer. Now let's have a look. We'll import the PDF file that we just made, and here it is. I clicked the shaded button. I also clicked the C button on the keyboard to center the view, and as you can see here, every time you click it, it switches between the center of the model and the origin. So, and if you click the shaded button, you can see a little better the element surfaces. So the mesh looks pretty clean. Of course, I did not make a very complicated geometry here, so yeah, this is good. We have the elements. We can select them, and we'll actually, whenever you import a mesh, you get an element set automatically. It creates element set 999, and that's all of the elements, so we don't need to make a new element set actually, but we will need to select all of these nodes. So we can select these up here, and let's select these down here. We're going to use these as boundary conditions. So you hold the shift button and drag select, it will select or add to your selection. If you hold the control button on the keyboard and drag select, it will unselect. So we'll just select. It doesn't matter. It's I'm just showing here, but I'll use this as node set number 2, and here we can select for node set number 1. So we'll just use these to lock the mesh in the X and Y direction. There, and yeah, that's good enough. We'll call that node set number 1. Now, of course, this is three-dimensional, so we also need to lock it in the nodes in the Z direction, but we can do that with the on both of these, both node Z1 and 2. So yeah, it's not doesn't have to be very complicated. Just to show you here how it works. Next, I'm gonna select some of the nodes here on this surface. Well, actually, let's do like this. And hold down the control button on the keyboard and drags to unselect there. So we have those surface nodes there. That can be node set number 3. And finally this one. We will select some of those surface nodes there, unselect, and there we go. That can be node set number 4. Alright. Now we need to create a section. So I clicked the create section button here, and let's make this stainless steel. And it's just it's a 3D tet mesh, so you just need the materials here. No, you don't need these. These are for beams and 2D elements. And we will take this section and apply it to the element set 999. That's the one that has all of the elements. And here you can see this changed to applied, which means all of the elements now have section properties. And we will now make a solution. So click the static button. We can keep the name solution 1, and we'll apply boundaries node set 1 in 1 and 3 direction, 0 displacement, and click the current solution button here, and we can see where the boundaries are applied. Also, this is very not realistic at all, but you know, we're just showing how the program works here. Node set number 2, 2 and 3, 0 displacement. So it's now, this is not going anywhere, and we'll apply one load here and one here. So click this uniform load button, and node set number 3 we will have let's say 60 newtons in the X direction. Okay, so it's now it's spread 60 newtons out uniformly on all these nodes. And I guess this is downwards, so but yeah, no, well, this one is bigger, so this should be able to take a higher load. This one is more slender. We give it a a smaller load. Node set 4. So the last one was 60. We'll give this one 30 in the negative y direction. And there we go. It's ready for the solver. So let's write the solution file. We can call it solution file 1. And we want stresses and displacements. Okay. It's solution file 1 has been created. So now you can click the Run Solve File in Solver button and select the solution file we just made. And this time you can see it's running a bit slower than previous tutorials, because there were more. Well, actually, I'm not sure if there were more degrees of freedom, but well, it's probably that's why. So the solution is now finished. We can open the solve file 1 out file, and here we see now new results available, displacement and stress. So let's click this current result button, and let's have a look at the displacements. They are, oh yeah, they are very small. This one can take a lot more force than we applied. We can look at the stresses. They are probably very small. Yeah, just 5 megapascals in here. So, and the mesh is maybe a bit coarse, so maybe you want a finer mesh. Then you can in the Gmsh you can go in this tools, options, mesh, and you can set this maximum and minimum element size, and it will create smaller elements for you if you need that. But mostly we want to know what the cross section looks like, and how the stresses are distributed. So you can select elements and then click the hide elements button, and just remove the unselect, and here we can you can use this to look what the stresses look like inside the part, and also you can click the average stress strain button to smooth out the mesh, the stress plot a little bit. So obviously here, if this was, I mean, these stresses are so small, it doesn't matter. But if this was an area of concern, then obviously this should probably be mesh, a finer mesh than this. And you can click show elements here to restore the stress plot. So, well, it's obvious this is the weak point. If if this preliminary solution with the very coarse mesh is an indication. So yeah, now you know how to create a 3D TET mesh in Gmsh and export so that it export it to a Nastran bulk data file, which can then be imported into Solfem. And I hope you find that useful. So thank you for watching, and have fun.